I hope everyone's doing great. I am Mr. Ish. Thank you for joining me. In this video, we're looking at two questions which will form the basis for the most basic aspect of functions, that is the definition of functions. The question number one is this: which of the following tables represents values that would represent a function? We have x and y in each case. This is your input, output, or your domain and your range. In each case, you have that. Looking at each table, you have to check which of these represents a function. The basic aspect you want to think about with regards to functions is this vertical line test. If you were to plot your points and draw a line or a curve, if a vertical line were to cross that curve at a single point, or your line at a single point, then you indeed pass the vertical line test and you would have a function. If you cross that curve or your line at more than 2 points, 2 or more points, you do not have a function. When you're looking over here, you're looking at a one-to-one correspondence between x and y. For each x value, there's only a single y value, and that does not repeat as you see over here. If you were to graph it, you could see something like this, a linear line. This is not drawn to scale, but you have a linear line or a linear segment, and a vertical line would only cross every point at one area only, and this indeed would represent a function. These points here clearly represent something from a function. When you're looking over here, do you have one-to-one correspondence between x and y? Well, you're seeing a -3 and a 2, a 3 and a 2, and a 4 and 1. Multiple x values which are different can all correspond to a single y value. That's fine. That's the basis of what you see in terms of horizontal lines. Here's a -3, here's a 3, here's a 4, nothing drawn to scale, but you're seeing something like this right here. You have a horizontal line over here. So when you're looking at this in terms of a vertical line test, it indeed does pass the definition of function, and all of this right here, these two are indeed functions. Remember, you can have multiple different x values all correspond to a single y value. Even this could have been right over here 2, and then everything here would be a horizontal line in terms of a depiction, and it would still be a function. Now when you're looking over here, you have a same x value corresponding to two different y values. You could technically erase this and you could do an arrow representation such as that, and now you don't see a one-to-one correspondence. You have a single x value giving rise to two y values. If you were to graph it, you have a 2, here you have a 1 and a 2 and a -1. If supposedly that were your curve, a vertical line would cross this at more than 1 point, and this right here would not be a function. So this right here table does not represent the values of a function, but these two over here do. Let's look at these three table of values and answer the same question: which of these represents a function, which of these does not? When you're looking right over here, just see if there's a one-to-one correspondence. Each of these different x values is corresponding to a different y value, and I'm seeing a one-to-one correspondence. If you're unsure, just graph it out. Here's -3, 0, here's -1, 1, here's 0, 3, 1, 1, and 3, 0, and it looks like a curve like that. If you were to draw vertical lines, it would only cross at 1 point, and it would easily pass a vertical line test, and this indeed would represent a function. Now look at this. Are you seeing a one-to-one correspondence? I am. For each of these x values, you're seeing a different y value. Again, if you want to graph it, you can. For a value 1 over 100, you're seeing something very far down over here, then 1, 0, then 2, 3, then 5, 10. You're seeing something which looks like this. And this indeed would easily pass a vertical line test. You would only cross your curve with the vertical line at only 1 point, and this right here would also be a function. Now look right over here. You have 2, 5, 2, 6, 2, 7, 2, 8. If you were to graph this, here's your 2, and then here's your 5, here's your 6, here's your 7, 8 in terms of y values, and you're generating a vertical line. A vertical line drawn through this vertical line would cross it at many points. Therefore, this right here would not represent a function, and it would fail. The reason why it would not represent a function, because a single x value is associated with multiple y values, which spoils the case. A good way to remember it is this, and I'm going to put it out for you right over here. And this could be like a little trick you can remember, or a tip you can remember. At any time you see something which looks like this, plus or minus x, y, that's okay. You have two different x values giving rise to the same y value in terms of a function. But anytime you see something like this, x, plus and minus y, that's not okay in terms of a function. It's fine for any other reason. But if you see something like this, you won't have a function because it won't pass a vertical line test. Something like this would pass a vertical line test. You would see something like this in terms of a parabola, you know that. You would see something like this in terms of a circle. You know circles are not functions because a vertical line can cross at more than 1 point. But you know parabolas are functions because a vertical line will always cross at only 1 point. This is what you would see in a parabola. This right here is what you would see in a circle, and you could also see this in a right or left facing parabola. So you can think of it that way. This right here is only for an up and a down facing parabola. This is for a circle and for a right and for a left facing parabola. These are types of curves which are not functions. And that's about it for this particular video. Thank you for watching. Have a great day. Bye.